So today we are going to be looking at general IUPAC naming conventions. So Kaplan book likes to split this up into 5 general steps, and I'll break those down right now. So first, we have to identify what the parent chain is. So the parent chain is essentially our main structure. It is our chain with the highest number of carbons. It's our chain with the highest number of substituents. And the chain also includes our highest order functional group. Highest order functional group, HOFG. And this functional group will provide the suffix for a parent chain. It's important to note that the substituents are functional groups that are not a part of the parent chain. Not a part of the parent chain. It kind of branches off, and you'll see what I mean here in a minute. The parent chain. So, first step, pretty simple. Identifying the parent chain really isn't too hard. Numbering the chain. This could be a little trickier. Number the chain. So what we have is we want to put our number 1 carbon as the carbon that's closest to the highest order functional group. And our second rule of thumb is that we want to number it such that we have the lowest number of prefixes for our substituents. So for example, if we have something like this, where we have an aldehyde here, aldehyde on the other side, and we have an ethyl right here. So, as you notice is that the oxidation state on both of these alpha carbons is the same because these are the same functional group, obviously. So, what we do is we want to number it so that the prefixes for the substituents are the lowest. So, say I start numbering from this side. This is the first carbon, second carbon, third carbon, fourth carbon. And I get 2 for my ethyl group, 2 ethyl. If I start numbering from the other side, I get 1, 2, 3, 4, and I get 3 for my ethyl group. So, obviously, we're going to number it with the pink because we have the lowest number for our substituent group. Important general concept to note here is that oxidation state increases. So oxidation state increases with more bonds to heteroatoms. Bonds to heteroatoms. So what heteroatoms are is they're primarily just atoms that aren't hydrogen or carbon. The main examples we'll see here is oxygen and nitrogen. Those are our big examples. Okay, so 3, naming our substituents. So again, it's important to remember that our substituents are the functional groups that aren't a part of the parent chain. So if I had something like this, for example, say this, right? So in order to identify my parent chain, I would say, okay, I could do 1, 2, 3, 4, 5. Or I could do 1, 2, 3, 4, or 1, 2, 3, 4. Looks like 5 is probably going to be my best bet, right? Because that's the most amount of carbons. So what I see here, I see, okay, I have some branch, and this branch is known as our substituent. So if I wanted to identify the substituent, I see, okay, there's a carbon here, but this carbon is a part of the parent chain. So I look out here, and this is an inherent carbon as well, right? And since we don't have anything explicitly written, we implicitly configure that these are hydrogens attached to the carbon. So this is a methyl group. Right? So that brings us to our first point. So when we're identifying substituents and we have an alkane, the suffix of the alkane becomes YL. So in this group, methyl or methane became methyl, right? And depending on the number of substituents that we have, so if I had, say I had another carbon here, then I would have two methyl groups. So I would have dimethyl. So our prefixes will also depend on how many of that substituent we have. So really, we only really need to know up to 5. It can continue, but the first, or if we have 2, it's di. If we have 3, tri. 4, tetra. 5, penta. There are some functional groups that we should be aware of as well. So assume that these carbons are terminating, so there's nothing else attached to the carbons on the outside, and that when there's a blank space left here, it's going to be bonding to some parent chain. So this is known as tert-butyl. Tert-butyl. If we have 5 carbons, all attached like this, this is known as neopentyl. Neopentyl. If we have 3 carbons, and this is a really common one, this is known as isopropyl. Right. We have 4 carbons bonded like this. This is sec-butyl. And then we have, again, 4 carbons, but instead bonded like this. And this is isobutyl. So fourth step, number the substituents. This is a pretty self-explanatory step. If you can identify the carbon chain and where to number the first carbon, this is a pretty easy step. Not really going to go over it. And then 5, complete the name. So substituents are in alphabetical order. And so usually with the prefixes we ignore them, but there are a couple examples in which we don't. So in cases like iso, neo, and cyclo, we don't ignore. We don't ignore that prefix to the substituent when ordering them in the main chain. Don't ignore prefix. So the only reason that we don't ignore these is that they aren't hyphenated. So things like tert-butyl, right? So this one's hyphenated, so we ignore the T. Neopentyl, this isn't hyphenated, so we don't ignore the N. Same thing with isopropyl, isobutyl, and then sec-butyl as well with the hyphen. We are going to ignore the di, tri, tetra, tetra, and so on. That's just common convention. So for an example here, we're going to name this hydrocarbon. So my first step, identify the parent chain. So let's see, I want either the most amount of carbons, and if there's a tie for the most amount of carbons, I want the highest number of substituents. So let's see, I do 1, 2, 3, 4, 5, 6, 7. That's one chain. I could do 1, 2, 3, 4, 5. That's not going to work. 1, 2, 3, 4, 5, 6. Close, but not going to work again. Or 1, 2, 3, 4, 5, 6. So looks like what we need to do is leave it like this, because this gave us the highest number of carbons. So we identified the parent chain. We numbered the parent chain. Now we need to name our substituents. So this right here is our parent chain. Anything coming out of this purple blob is going to be one of our substituents. So the first ones I'm going to look at is, let's see, a methyl on 5 and a methyl on 6. See, I've actually made a bit of a mistake here in numbering these, right? So I want to number it such that the prefixes for the substituents is the lowest, but if I do it this way, I get it to be the highest. So I'm going to redraw the molecule. Redraw the molecule like that. We're going to number it correctly this time. So this can be our 1, 2, 3, 4, 5, 6, 7. And again, okay, now we can name our substituents. So first thing I notice are these two methyls. So I see, okay, there's a methyl on 2, on the 2 carbon. There's a methyl on the 3 carbon. And there's 2 methyls, so it's dimethyl. Right? And then 4, I look at 4 and I say, okay, that's 1, 2 carbon, so it looks like it's going to be an ethyl group. Right? And then my main chain is 7 carbons long, so that's heptane. So what I'm going to do is bring it all together. Remember that these are in alphabetical order and we ignore some of these prefixes. I don't have iso, or cyclo, so I can just jump straight in. I see E comes before M, so 4 ethyl, 2, 3 dimethyl heptane. And this is our name for this molecule.